Hello everyone, you are welcome to my YouTube channel. In this video lesson, I am going to be teaching you how to carry out traces on refraction of light through rectangular prism without actually carrying out the experiment. As we already know, whenever we are exposed to an experimental work in physics or even in chemistry, instructions are being provided and we are expected to follow the instructions in order to arrive at certain results which we are expected to analyze. In one of my video lessons, I had actually demonstrated live how to carry experiment using this rectangular prism. If you want to study refraction of light through a rectangular prism. And so I really want to use this opportunity to encourage you to watch that video. Towards the end of this video, in just a few seconds to the end, you will see a thumbnail that will appear. Please, you can click that thumbnail in order to watch the live demonstration of the experimental determination of Snell's law, where we study refraction of light through rectangular prism. Like I said, the purpose of this particular video lesson is to teach you how you can run this experiment, carry out your traces without really performing the experiment. Does it mean that the GMAETS 41 is teaching you how to escape or by cut carrying out the experiment, perhaps in exam or maybe when you are exposed to a laboratory work? The answer is no. For one thing, the GMAETS 41 always encourages students to carry out the live practical whenever it is necessary for them to do that in the laboratory. This video is just a kind of an added assistance when it becomes necessary if you are choked with time. If you have the time, please, I encourage you to carry out the experiment. Alright, before we move on into this experimental work, I would like you to please watch the screen as the instructions guiding this experiment displays. Please watch and read through. Good. I hope you read through the instructions. So we are going to follow the instructions and then construct our traces. Take note, construct our traces for the refraction of light through the rectangular prism without actually carrying out the experiment live. But before showing you these, I would like to state in clear terms, please, your first experiment is important you carry it out. I repeat, your first experiment is important you carry it out. That one on the angle of incidence of 20 degrees. The reason for that is you would need that incidence angle, you would need the angle of refraction. Is that okay? These two angles, you need them to calculate the refractive index of the rectangular prism. You need the incidence angle and the angle of refraction to calculate what I said, the refractive index of your rectangular glass block or prism. It is this value of refractive index that you would now use to construct your other traces. If you do not know the value of the refractive index, you may not be able to actually do the other constructions without live experiment. So remember this, if you find yourself in the laboratory, you want to carry out at least one of the experiments, use the value of the incidence angle and the refracted angle to determine your refractive index using Snell's law. Please watch as I show you how you can do the constructions of 70 degrees. So here we go. Now this is the rectangular prism. You're going to place it on the plain paper and then trace the outline. So this is going to be something like this. I'm sorry that I'm using pen, please. If you're carrying out this experiment, you are meant to use pencil. I'm using pen so that you can see this clearly, okay? Pencil is what you are meant to use. Good. I've traced the outline of this rectangular glass prism. The next thing I'm meant to do is to draw the normal. What is the normal? Just a line drawn at 90 degrees to the outline. Now this is A, B, C, and D, according to the diagram that guides this experiment. So I'm going to place my ruler along the outline AD. The total length is there about 10.1. Okay, so this would be the middle, supposedly, let's say 5. Somewhere, say 4 centimeters from A, I will locate it to be the point of incidence. So I am going to draw my normal there. And how do you draw your normal? This is your protractor. Now, this middle point of the protractor, where the 90 degrees line and then 0 to 180 degrees line met, will be at this point you are to draw your normal. Alright? Then the horizontal line of your protractor 0 to 180 is going to lie on the outline AD. Since the normal goes upward this way, you want to trace your point of 90 degrees. So watch as I place it. You want to be very careful as you're doing this so that you make sure that the protractor is on the required outline. Now, at this point, this is 90 degrees. Just make a point with your pencil. Then I'm using pen, but I've told you the reason. Shift off your protractor, bring your meter rule, your ruler, and then, make sure that the ruler, so the point where you want to join, then you draw your straight line. This is our normal, labeled as N, according to the diagram guiding us. Now we are meant to measure the angle. So 70 degrees, please. Let's go. We are going to measure 70 degrees away from the normal. Now the normal is at the point 90 degrees. 70 away from 90 is going to give us 20 degrees. What do I mean by that? To get 70 degrees away from 90, you are going to move down to 20 degrees. Look at it, from 90 to 80 is 10 degrees. To 70, 20 degrees, like that. 30, 40, 50, 60, and then to 20 you now have 70. So at that point of 20 here, I'm going to locate it with just a point. I'll bring back my meter rule, and then I will join this point to this point of normal, this point of incidence, okay? I'm going to draw my incidence ray. So, we have this. If you were to carry out the experiment live, you see, at this point you are meant to fix 2 pins here and here. Then you start doing your tracing here. You replace this glass block and then trace. But we don't need that. That's what I'm trying to say. The pins should go and rest. Okay? Now, at this point, what am I going to do? This is the angle of incidence, which we have gotten I to be 70 degrees. I am going to calculate the angle of refraction. Now, if I have the incidence ray, I think here was labeled as M, this point labeled as P, according to the diagram. Okay, you saw the diagram just before the instruction. Now, I am going to calculate the angle at which this incidence ray will refract once it enters this glass. Now, it is assumed that the light is coming from air into glass because all the surrounding of this glass block outline is taken to be air. Light is traveling from air into glass. Now, air is less dense than glass. In other words, glass is denser than air. So now that light is coming from air into glass, when the refraction is taking place, the light ray will be drawn towards the normal. It will be pulled towards the normal. So the refracted ray is going to be something like this. But I cannot just draw any line anyhow and then call it refracted ray. I must calculate the angle at which the refracted ray will bend towards the normal. And that is why I will move on to use Snell's law. Snell's law simply says that N is equal to sine I all over sine R. This R is angle of refraction, which I need here. So if you make our R subject to a formula, you watch, the formula goes this way. R is equal to sine inverse, open bracket, sine of angle of incidence divided by the refractive index of the glass. So this is the formula we need to use in calculating our refracted angle of refraction. So at this point, I will move on to say R is equal to sine inverse, open brackets, sine of angle of incidence, which is 70 degrees now measured. This is already given in the instruction. I'm going to divide it by the refractive index of the rectangular prism, which I told you already when I ran the life experiment for incidence angle of 20 degrees. I used that incidence angle and the refracted angle I obtained. I think the refracted angle at that time was 15 degrees or so, right? That 15 or 14. And so when I did that, I calculated this refractive index N of this glass to be equal to sine I all over sine R. It gave me sine 20 degrees all over sine 14 degrees thereabout. So when I evaluated that, N, the refractive index of this glass, gave me 1.4 approximately. So we know the value of that already, N. I have already substituted it. And then we shall calculate our angle of refraction. That will be sine inverse, then evaluate sine 70. Get calculator, sine 70. So it gave me 0.9397 approximately, sine 70. So this is going to be divided by 1.4. I think I can evaluate this straight on. Sine inverse of 0.9397 divided by 1.4, and then it gave me 42 degrees. 42 degrees. Please, you are meant to use a whole number for this, not point anything. Like here is giving me 0.1. If you approximate this, you're going to get 42. If it is 42 point, say something like 5 or 6 or 7, you can choose to approximate to 43 degrees. Are you following, right? You do not record anything, angle of incidence or angle of refraction, as whole number points, in decimal form. You don't do that. The reason is because your protractor is not calibrated in any decimal value. Think your protractor is in one whole number unit, okay? So you cannot get point something if you are measuring with this instrument. Now that I have gotten my angle of refraction, I would now measure the angle of refraction to this normal. How do I do that? The angle of refraction is going to be formed somewhere here, just like you have the angle of incidence. So if maybe I have my refracted ray this way, the angle of refraction will be inside, something like this. Therefore, the angle of refraction is going to be formed at this point of incidence. On the basis of that, this middle point of the protractor will be placed at this point of incidence. Then the 90 degrees line of the protractor will be placed on this normal. And then I'll measure 42 degrees from it. So something like this. The 0 to 180 line, once again, will be on the outline AD. So let's see. Good. I got it now. So I'm going to measure 42 degrees from 90. Moving this way. Are you getting me right? Because the angle is formed between the normal and the refracted ray I'm going to construct. So we are going to get something like this. This is shifted. Let me adjust. Good. From 90 to 80 is going to give us 10 degrees. You can decide to follow this angle marking. You know, from 90 to 100, 10 degrees. But either way, the choice is yours. 90 to 80 is 10 degrees, to 70, 20 degrees, to 60, 30 degrees, to 50, 40 degrees. Take note, you are measuring 42. So when you come to this 50, that is 40 degrees, you move to this small line, 41, the next small line, 42. Then put a point there. Make a mark there and then shift your protractor, bring your ruler, then join this point to your point of incidence. You have to draw it to touch face B, C of your rectangular prism outline. Almost at the vertex of this prism. Anyway, let's see. So this angle is our angle of refraction. It's 42 degrees as calculated. Please, this calculation, you are not meant to do it on your tracing paper. The reason is this. Your examiner wants you to do this live. But you did not do it. You rather constructed. So you showing this calculation is going to expose you. My God. I'm sorry. Okay? So don't do this calculation on your tracing paper. You can do it as a rough work somewhere, okay? Please take note of that. Otherwise, you will be caught that you didn't carry out the experiment you constructed. And that is wrong if you were actually meant to carry out the experiment live. Like I said, I'm teaching you this so that possibly if you have a situation in exam or so where there is no time, you can actually work on this and do your traces rather than you construct your traces rather than doing the live experiment where you will bend, you close one eye, you block another thing. You know what I'm talking about. So please don't do these calculations here. Don't. All right, now at this point where the refracted ray touched face BC, I am going to draw a normal there. And how do you get your normal? The same as you obtained it here. I'm going to place my protractor this way at this point. So the middle point of this protractor is going to be at this point where the refracted ray hits the face BC. Then the horizontal 0 to 180 line of the protractor will lie on face BC. So something like this. Then I will make a point here at 90. So I can be able to join that point to this point in order to get my normal. Good. Now, you know that the ray coming from the glass now into air will produce another ray that we call the emergent ray. Once the refracted ray hits this face, the next thing is for it to come out into air. So it is coming out from a denser medium, which is the glass, to a less dense medium, which is this surrounding space, the air. So, you know clearly, since the light is now traveling from an optically denser medium to an optically less dense medium, the ray coming out here is going to bend away from this normal. It's not going to bend towards the normal. So we expect something to go like this. But you don't just draw the line anyhow you want, the emergent ray. You must measure the angle away from the normal where the emergent ray will pass. And like I said, that angle is going to be equal to the angle of incidence. But if you still want to calculate that angle, it's going to take the formula 1 over the refractive index of the glass equal to sine R, which is sine of the angle of refraction, because this angle is alternate to this angle using the knowledge of your geometry in mathematics. So we are just interested in getting ratio of the sine of this angle to ratio of the sine of angle of emergence. So this is going to be over sine of the angle of emergence. So that if you make this emergent angle subject to the formula, it's going to be sine inverse of you cross multiply first. The refractive index times sine of angle of refraction. If you solve this, let me fix up the values. Sine inverse 1.4, which is the refractive index of this block, then sine of the angle of refraction, which already the angle of refraction is 42. If you work this out, you should get 70 degrees approximately, if not exactly. Okay, so the angle of emergence measured away from this normal is going to be 70 degrees. So I'm going to place my protractor this way, just exactly the way I obtained the normal, and then measure 70 degrees from it. Good. 70 degrees measured from 90 should take us to this 20 degrees at this point. So you make a point there. Should take us to 20 degrees. So look at it. What I now have to do is get my ruler, and then I'm going to join this point to the point at which the refracted ray hits face BC. We call it the point of emergence. Why this one is the point of incidence. Good. So this is your emergent ray. This angle is the angle of emergence. It's equal to the angle of what? Incidence. This is good. I think at this point here was labeled, let's see, Q and R. Q and R. This Q and R are the points, where these pins are meant to have been placed. Where these pins are meant to have been placed if you are carrying out the experiment live. Pins 3 and pin 4 are meant to be used to block the image of pin 1 and pin 2 that will appear in the prism if you are carrying out the experiment live. But like I said, we don't need the pins. Just trying to show you if you were to carry the experiment live. Now at this point, we are going to construct the circle here using a convenient radius. The instructions say we should use a radius that is not less than 2 cm. Now this radius is 2.5. I've set it already, so I'm going to use it to construct this circle. Is that okay? So watch as I do that. Good. I have drawn the circle. The radius of the circle, like I said, is 2.5 centimeter. Now this point, the instructions say we should take note of it. This point where the circle cuts the incidence ray and the refracted ray. Then this point was labeled as U, and this one was labeled as S, following the instruction. Now we are to draw a line that will be perpendicular to the normal from this point U. Another line that will be perpendicular to the normal from this point S. To achieve that, you bring your protractor. The horizontal line of the protractor will lie on the normal. Then this 90 degrees line will be placed in such a way that it passes through this point S, so that the line you're going to draw will be purely 90 degrees to the normal. So something like this, watch. Good, you can see that now. All right, and then at this point, make a mark here showing that you've gotten the 90 degrees. Bring your ruler, take note of this, but don't draw the line from here. Come to this point and then you draw. Good. So this point is labeled as V. Okay, all these labels are based on the diagram that is guiding this, because there's a follow-up diagram in the instruction. In the same way, we are going to draw another line that will be perpendicular to this normal. Now, that line is going to be drawn to this point U. How do we achieve that? Still the same way we achieved this VS. In a similar way, this 0 to 180 degrees line is going to be placed on this normal, and then the 90 degrees line is going to be adjusted to pass through this point. So watch as I do that. Good. So you notice the 0 to 180 degrees line is lying on the normal, and then the 90 degrees line pass through this point of U. Come to this point and then make a mark at that 90 degrees. Remove your protractor, bring your ruler, adjust the ruler to make sure that it passes through this point of 90, through this point of U. Remember, you are joining this point U to the normal. Good. This shows clearly that this line met the normal at 90 degrees. This point is labeled as T, giving us our UT and VS that the instructions said we should measure. So what do? This length, I'm going to measure it. Length UT. TC. Length UT gave me 2.5. 2.5. So one can just record UT equal to 2.5 centimeter. And then we're going to measure VS. Same way, take the meter rule to VS. And then we have 1.8 centimeter. Alright guys, this is just how you carry out this experiment. Alright, constructing your traces in rectangular prism experiment in the verification of Snell's law without carrying out the real life experiment. You can use this to beat up time, but the point is you have to be as fast as you can, and then you should remember this little calculation, very important. The determination of the angle of refraction, okay, because you need to get it so as to be able to draw this refracted ray. And don't forget, like I said, the angle of emergence that will help you to get the emergence ray. You don't need to stress yourself there. I did the calculation here, but you don't need to stress yourself because the angle of emergence is equal to the angle of incidence. So this is it, and of course, I hope you enjoyed it. Please, you can like and subscribe to my YouTube channel and share the video lesson. You can also become a channel member in order to support this channel and gain more benefits exclusively for members. In the next video lesson, I am going to plot the graph of this experiment and of course do the necessary analysis required, like getting the slope, the intercept, and statement of laws of refraction. Of course, I can even say that there are two laws of refraction. The first law states that the incidence ray, the refracted ray, and the normal at the point of incidence, all of them lie on the same plane. Look at this plane AD. So you notice that the incidence ray, the refracted ray, and the normal, they lie on the same plane. Then the second law of refraction, which is called the Snell's law, states that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of medium. And that is what you have here. So these are the two laws of refraction. Please follow me, like I said, in the next video lesson where I plot the graph of this experiment. Because we are asked to plot, is it UT against VS or VS against UT, whichever. You're going to see that in the next video lesson. Please enjoy your day and take your studies seriously as always.